Here I'm gonna demonstrate how to solve system of equations, including linear function and quadratic function. So first, the first task here is to graph the two curves. Okay, there's y1, there's y2, and here is the requirement. What if a line intersects with a parabola? Parabola comes from a quadratic function. And here, first, what we do is we graph the two curves in one picture, with Excel. Okay. And here the domain is from 0 to 12 with unitary increment in x. Okay. So this is what this video is gonna handle. So here, x from 0 to 1, okay? And then we can drag down. Look at the right bottom corner. It says 12 here. So that tells you we're dragging down to 12 with an increment, unitary increment in x. Then y1, 13 minus 2 times of x. And y2 is x minus 6 squared plus 2. Okay. And then we apply those calculations of y1 and y2 for all those x's, right? It's 13 minus 2 times of a7, which is when x equal to 3. And here, a9 minus 6 squared plus 2 when x equal to 5. That's good. All right, so now this is the first step, which is to graph them. And we're still going to use line with marker function. Okay, and we're going to select data. Here we add the first entry, which is y1. Oh, that's the line. Okay, that is y1 here. Okay, and let's add another one, y2, which is a curve or parabola. So here for convenience, I just choose curve, which is a shorter entry. Okay, so that's y2. And here, don't forget to change the domain of x to make this curve more accurate. Okay, so here it is from 0 to 12, and we can see when x equal to 5, there is only one intersection. Okay, so that's the first part of solving this problem. Okay, now let's look at the third part, which is work out the coordinate of the intersection point by Excel solver. So actually here we can use difference method. The difference method. Actually, we have learned this in our week 1 for solving system of equations as well. And here it's nothing new. It's still to solve system of equation. Okay. And what we do is the only difference is the system equation now has a quadratic form in it. Solve difference method. Okay, so still, let's copy down this to functional form. Okay, here if we solve them by hand to solve for the intersection point, as you can see at this point, this very point, right? The x1 applies to this line, and x1, the x and y coordinate both apply to this line and this curve, right? So at this point, when x equal to 5, y1 equal to y2. That's what intersection point is. So here, for intersection, that is when y1 equal to y2. Okay, so here we just need to use solver to realize that. Okay, so x still is the choice variable, the independent variable. y1, let's just type out the equation, but invoking the cell that stands for the value of x. So 13 minus 2x. And y2 is x minus 6 squared plus 2. Okay, so here, how can we make y1 equal to y2? That is when the difference between these two equal to 0. So that is our target. We are to find x so that the difference between y1 and y2 is eliminated. So now let's use solver to realize that goal. Okay, so what are we going to do? We're going to change the value of x so that the difference is eliminated. Okay, so let's solve it out. And here the result is x equal to 5. And here we can also read out when x equal to 5, y1 equal to 3, y2 equal to 3. So here the coordinate of the intersection point is 5, 3. Go back to the graph. Here, it's the height is less than half between 0 and 10, less than 5, and here 3 actually falls in that location. Okay, so lastly, that's question 2. Work out the coordinate of the intersection point by hand. So I'm gonna quickly demonstrate that. There's 2a, example C. Now let's switch to my document camera to show how to do this by hand. So here, there are several things. y1 equal to 13 minus 2x, y2 equal to x minus 6 squared plus 2. Okay, so when a line intersects with a curve, this x and y both apply to the line and the curve, right? So when intersection, let me say, upon intersection, y1 equal to y2, right? That's when 13 minus 2x equals to x minus 6 squared plus 2. Okay, now let's just expand the right-hand side. 13 minus 2x, we just copy it down, equal to x squared minus 12x plus 36 plus 2. Right, just to remind, a minus b squared equal to a squared minus 2ab plus b squared, where now a is x, b is 6. Okay, so it's x squared minus 2 times x times b, which is 12x, plus squared of b, 36. Okay, so that is x squared minus 12x plus 38. I just add 36 plus 2 into 38. So now let's change this into an equation. Let's just move everything to the right-hand side. The left-hand side turns into 0. The right-hand side is x squared minus 12x. Now minus 2 move to the other side. Oh, let's just do it step by step. Minus 2x move to the other side. Change into positive 2x. 13 minus to the other side. change into minus 13. So it is x squared minus 12x plus 2x, that is minus 10x, plus 38 minus 13, that's 25. So the result is x squared minus 10x plus 25. You can use the, you can plug everything into the formula. That's what you can do. But here, I'm acute enough to detect that this quadratic is nothing but x minus 5 squared. So we want this equal to 0. It holds, this equation holds only when x equal to 5. So x equal to 5 is coordinate, is the x coordinate of the intersection. But here we need to find the intersection of both x and y. So for y, you can plug x into 5 into this or that. The linear one is easy. So I'll just plug x into 5, x equal to 5 into y1 equal to 13 minus 2x. And here that is 13 minus 2 times of 5, which is 10. So 13 minus 10 equal to 3. So that's how we solve this by hand.